Way up at the top of the world, blasted deep inside an Arctic mountain, there's a vault. It's not holding gold or diamonds, but something way, way more valuable. A complete backup of our entire agricultural history. To really get why that's so important, we have to start with a pretty big question.
Seriously, think about it for a second. If you had to save just one thing to make sure civilization could rebuild, what would you pick? Famous paintings? Classic books? All of our technology? Well, the real answer might not be what you think.
It's the genetic diversity of everything we eat. The actual blueprints for our food. And the Svalbard Global Seed Vault, well, that's our species' ultimate insurance policy, built to protect those blueprints from pretty much any disaster you can imagine.
Now, when most people hear about this place, their minds jump straight to Doomsday Vault, you know? Like it's just sitting there waiting for the apocalypse. But that kind of misses the bigger picture. This vault isn't just for some far-off catastrophe. It's an active, vital tool we need to secure our food supply right here, right now.
So why on earth would you build the world's most important library at the literal ends of the earth? Why Svalbard? Well, the location was anything but an accident. It's this perfect storm of geology, geography, and even geopolitics that makes it the ideal fortress for our food.
The choice of Svalbard was incredibly strategic. First off, it's just really, really remote, which is a great form of natural security. It's also a demilitarized zone, thanks to a treaty from way back in 1920, so it's totally neutral ground. Geologically, it's rock solid, built right into stable sandstone. And here's the kicker. It's surrounded by permafrost. That's a natural freezer that acts as the ultimate failsafe. So even if the power cuts out for good, the seeds stay frozen. Oh, and it's 130 meters above sea level, so it's safe even from the absolute worst-case sea level rise scenarios.
And while that permafrost is a great natural backup, the vault itself is kept at a precise, mechanically cooled -18 degrees Celsius. At that temperature, all the biological processes inside the seeds slow down to a crawl. It's basically like putting them in suspended animation where they can stay viable for hundreds, maybe even thousands of years.
Okay, so the engineering is brilliant, right? But that's only half the story. The real genius of the vault, what makes it all work, is the governance. It's a whole system built on trust with a simple set of rules that lets countries from all over the globe, even rivals, work together.
So how is it managed? It's this really clever three-way partnership. The Norwegian government owns the building and pays the bills. A group called Nordgen handles the day-to-day work, managing the deposits. And the Crop Trust, which is an international organization, helps fund gene banks all over the world so they can participate. The whole point is to make sure no one country or group has total control. And all of this is possible because of one crucial rule, the black box principle. The easiest way to think about it is like a safety deposit box at a bank. The bank owns the vault, but you, and only you, have the key to your box and own what's inside. It's the exact same idea here. The country that deposits the seeds never gives up ownership. They're the only ones who can ever open that box.
And this isn't just some handshake deal. It is a legally binding guarantee. This is the absolute bedrock of the entire system. It's the foundation of trust that convinces a country to send its priceless national heritage to this remote vault in Norway. Without that guarantee, the whole thing just wouldn't work.
For years, this was all a great idea, a fantastic insurance policy on paper, but it was one we all hoped we'd never actually have to cash in. Then, a real-world crisis put the vault to its very first and its most critical test.
The crisis started in Syria. A research center called ICARDA had a gene bank in Aleppo, and it housed one of the world's most vital collections of seeds from the Fertile Crescent. We're talking crops that are uniquely adapted to dry, tough climates. When the Civil War got worse, that entire priceless collection became trapped, and there was a very real risk it could be lost forever. But luckily, ICARDA had been thinking ahead. For years, they'd been sending backup copies of their seeds to Svalbard, just in case. So in 2015, when their main gene bank was cut off, they made the first ever withdrawal from the Global Seed Vault. They took those seeds to new facilities in Morocco and Lebanon, planted them, grew them out, and harvested the new seeds. And by 2018, they were already sending a fresh batch of safety duplicates right back to Svalbard. The system worked. It worked perfectly.
And we're not talking about a small test run here. The scale was just massive. They withdrew 38,073 unique seed samples. This was a full-blown rescue mission for the agricultural heritage of one of the most important regions in the world.
And in that moment, the vault proved its worth. It showed everyone that it wasn't just some museum for a hypothetical doomsday.
It was a living, breathing, and absolutely essential part of our global food system, a real lifeline in a moment of crisis.
So the Icarta story was this incredible proof of concept, but the vault's work goes on every single day, quietly securing our future in a world that is changing faster than ever. And the collection is just huge, and it keeps growing. As of 2025, the vault is safeguarding over 1.3 million unique seed samples, sent from almost 130 different gene banks. And there's still tons of room to grow. It has a maximum capacity of 4.5 million samples.
But here's a really important catch. The vault is specifically designed for what scientists call orthodox seeds. These are seeds you can dry out and freeze, like wheat, rice, or corn. But what about crops that can't handle that process? You know, like potatoes, or bananas, or avocados?
Well, that's where other systems, like the new cryovault in Peru, come into play. See, while Svalbard uses freezing at -18 for those orthodox seeds, the cryovault uses something called cryopreservation. It uses liquid nitrogen to get to a mind-boggling -196 degrees Celsius for those other, trickier crops. They're not competing, they're working together to build a complete global safety net.
You know, the success of the Seed Vault has been so influential that it's actually inspired a neighbor right there in the same mountain in Svalbard. It's called the Arctic World Archive, and it uses the same basic idea, secure long-term storage in the Arctic, but for a whole different kind of blueprint, our digital and cultural memory. So you have these two vaults, side by side, with similar goals but different approaches. The Seed Vault protects our biological blueprints in foil packets, and it's a free service for the public good. The Arctic World Archive protects our digital blueprints, things like open source code, on super durable film, and it's a paid commercial service. Together, they're turning Svalbard into a fortress for world memory.
But of course, a project like this is never finished. The challenges ahead are pretty clear. Number one is climate resilience. They've already had to make major upgrades to deal with a warming Arctic. Number two is expanding the scope, thinking about other things we might need to protect, like forest seeds. And number three, probably the most important, is just sustaining that spirit of global trust that makes the whole thing possible in the first place.
And that really gets to the heart of it all. The permafrost, the concrete, the engineering is all incredible. But as this quote says, the vault is so much more than that. It's a manifestation of trust. It's a powerful symbol of what we can actually achieve when we choose to cooperate instead of compete.
In the end, what we have here is a library of our entire agricultural past. It's a collection of answers to questions we haven't even thought to ask yet. The vault protects our genetic history. So the real question that's left for all of us is, who's going to use it to build our future?